mal auf Deutsch an. Mein Name ist Stefan Bente, ich bin Professor für Softwaretechnik an der TH Köln und ich habe das große Vergnügen, Sie heute durch diesen Track moderieren zu dürfen. Und wir haben als ersten Vortrag heute den Vortrag Deep Dive into Service Mesh Architecture. So it is evidently an English presentation, so I will switch to English. We have Arturo Viveros here, working for SYSCO AS in Norway. SYSCO is a consulting company dealing with DevOps, integration, infrastructure in modern architectures. Mesh or service mesh architectures is something that there's a current trend in loosely coupled architectures, large landscapes, IT landscapes, where you want to deal with like transparency, resilience, the ability to function as a large network. So I'm very much looking forward to this lecture, which is a hands-on lecture. If you want to ask questions or comments, you have two ways of doing this. You can either write a message into the chat, and I will pick out some of the questions and ask them to Arturo in the end. Or you can raise your hand, and then can give you the ability to speak. So we can ask live questions. So we can see there have some people raising their hand, and we can take 1 or 2 live questions. Unfortunately, we have to do a pretty strict timekeeping to enable people to switch between tracks. So enough from my side, handing over to Arturo. Looking forward to the lecture.
Yes, thank you, Stefan. Welcome, everybody. Thanks for joining the presentation today. And yeah, we're going to do a deep dive into the service mesh architecture. My name is Arturo, and we'll let's just jump right into the subject. So yeah, the first question that comes to mind is what is a service mesh? Maybe some of you have already heard about this or tried it out, and maybe it's the first time that you are hearing it for some of you, but that's fine. So but in that context, maybe it's better to start with what is a mesh, because as Stefan was saying, service mesh has become a trendy thing to say in IT these days, but it's much more than a buzzword. So in the spirit of staying away from the buzzword and really understanding what we are talking about, let's start with this little introduction. So what is a mesh? Like in everyday life, in plain English, so to speak, this is a very common concept. It's something we see every day, mostly everywhere. So it's something very simple. It's a barrier made of woven connected strands of metal or other flexible materials. And why do we need a mesh, or what do we use a mesh for? Basically, we use it for supporting structures like buildings, for example, to protect people or to contain stuff like debris in the industrial settings, or to provide an enclosure, like for example in a zoo. So this concept is present in everyday life. It is very common to see a mesh everywhere. The most common is this coiled wire fabric mesh that it's basically omnipresent. And what does it provide? Basically, as the slide is pointing out, protection, containment, boundaries. Why do we use it? Because it's quite resilient, but it is also flexible and transparent enough to avoid stonewalling, what we want to limit or protect, right? So, for example, in the zoo, we could as well use a concrete wall to protect the enclosure, but then we could, so not functional enough. That's why we want to have this kind of mesh, which is strong, but at the same time transparent. We can see through, we can work with it. So that's in everyday life. But something very interesting here is that this is also a very important concept, the mesh, in engineering. So in engineering, meshing basically refers to the practice of generating predictive models to approximate any kind of domain. And we typically do this by using polygons, which then are connected with a series of lines and points. I think in engineering, most of us, or if not all of us, have seen this kind of approach. It's very common. Most production lines, most product development processes are based on this theory. And most of the products we have around today wouldn't be there if this wasn't possible. So this is mostly about decomposing a big problem into smaller ones. Then we can model the behavior. Then we can have an accurate level of prediction. And engineers and scientists, they use this thing called finite element analysis to build the models. So what is finite element analysis? Again, just decomposing a big problem into a smaller one. And this is mostly computer aided on this day and age. So computer software allows us to do this kind of analysis and simulation. And this is important because it's very much in line with, for example, the microservices architecture, which has a lot to do with the service mesh, where what we want to do also is we are building software, we are building systems, but instead of tackling a huge problem, we will decompose it into smaller pieces, which are much more predictable, which we can have much more control of, and then that gets us closer to being able to succeed with this kind of task. So that's in engineering. It's a very interesting topic, and in software architecture, which is also a part of engineering, what does it mean to do meshing, to have a mesh? It's basically, if we transport the same concept we've been talking about to software architecture, it's basically decomposing our systems in smaller pieces that are more manageable, and then weaving them together through a series of lines and points in a congruent yet transparent fashion, which gives us enough flexibility, which gives us more sense of security and allows us to establish boundaries and protection and security as we talked with a coiled wire mesh. So that's a mesh. So yeah, with this in mind, let's. I just want to do a proper introduction of myself. As I said, my name is Arturo Viveros. I am originally from Mexico, but I'm based in Norway. My main areas of interest and expertise is software development, of course, infrastructure and cloud infrastructure in the latest years, service integration, data engineering. Most of the projects I'm working on have to do with data engineering, but you need to lay the foundation, the groundwork for that. And there is where a concept like a service mesh becomes super interesting and useful. So yeah, that's me. I'm glad to be here. I was looking forward to be in Germany with you, but I'm still glad that this happened and that I'm able to spend these 45 minutes with you in the digital format and sharing this information. So let's move ahead. And so now we can tackle the original question. What is a service mesh? What is a service mesh for software architecture, for software development? And the definition is actually quite simple. It's one of the simplest out there, I think. So a service mesh is an infrastructure layer that enables secure service-to-service communication. And in this context, very important to know that infrastructure doesn't refer to a piece of metal, like a server or an appliance. This is actually software that we will put in place as a building block or as a structural piece to build more software on top of it. So this is the kind of technology that we call nowadays infrastructure as software, or cloud native infrastructure could be. So for example, in the cloud operating model, ES, PaaS, and SaaS, the service mesh would be closer to the ES layer, actually, infrastructure as a service. So that's just hold that thought. That's very important, and we are going to discuss that in detail. But yeah, there's some misconception around, for example, the service mesh, where people categorize it more in the platform as a service space, but it's really a piece of infrastructure. So that's very important to understand, and we're going to see why. So this is the basic definition. It's a very good one. Now, to really understand the service mesh, which challenges does it address? So we already said its main purpose, its main reason to be, is to enable secure service-to-service communication. But there's a lot of challenges related to this, to securing service-to-service communication. So let's look at it from the most simple perspective to the more complex, and we will find out what are these challenges and how can the service mesh address them properly. So this is the simplest possible diagram, right? So we have a system with a couple of services that need to talk to each other. Service A needs to talk to service B. And we are inside our network, so in a safe zone, so to speak. By the way, throughout this presentation, we're going to assume that all of these services that we diagram here, they have proper APIs. They are able to talk to each other over HTTP. So that's an assumption. If they are not, then that's work for a different tool. But most services nowadays have APIs, and they are able to communicate over the network. So we'll assume that. So yeah, in this setup, many organizations don't. Many organizations think that if I'm inside my safe network, if I'm inside a system, then maybe I can leave this unsecured. So I can do this by plain HTTP, and maybe I put something outside, load balancer or a firewall or a service bus or whatever, to secure communication from the outside in. But that's probably wrong or not fully correct, because in a very simple analogy, let's say in your own house, you normally have a front door, right? And that has a lock. So that gives you some security, right? But if you have some valuables inside your home, like, I don't know, the jewels of the family or money or your passport or whatever, then you want to have some additional security for that. If someone breaks into your home, then you don't want the valuable things just laying around for grabs, so to speak. So probably you at least want to have another door with a lock in your own bedroom, right? Or maybe even you will have a safe inside where you put the most valuable stuff. And maybe no one's going to break in, but what if you do a big party? If it's not once Corona time is over, you do a big party and you invite like 30 people, and you willingly invite them into your home, and you don't know and trust all of them very well. So again, you need to put your valuable things in a safe place, even if you're inside your safe zone, which is your home. So it's the same with systems. You need to secure them. You cannot just forego security like this. So that's this needs to be secure. But what if we go to a little bit more complex diagram? And we're still in the same network, but we're talking about different systems. So now I need service A to communicate with service C, which lives in a different system. So then I not only need to secure this communication, but I also need to do routing and probably discovery. Since I'm in the same network, maybe the DNS takes care of discovery, but I need to be able to route from service A to service B. So that's a new concern, right? Service A, the system A, service A needs to know where the other service is, because it's not within the same system boundaries. That's another concern that needs to be solved. Let's go to a little bit more complex architecture. So what if we have separate networks? And this is the case. It's the most common nowadays. We work with different networks, even inside the same organization. But the organizations also work together with their APIs and services, and they need to communicate with each other automatically. So they need to extend their trust boundaries to cover several networks. So we have VPNs, or we have other means of communicating networks. So yeah, this is obviously much more important to secure, because I'm going from a different network into my own. So that needs to be super secure, right? But then we also have the question of service identity, because there's no human interaction here. There's no personal identity or human credentials. So if communication comes, if a request comes, the system B inside network A needs to know the identity of this service that is requesting information or is trying to do something. And it needs to be able to really confirm that the identity is the proper one. So that's another concern. We also need, in this kind of setup, compatibility between the networks, right? So that's another concern. But it's normally much more complex than that. So what we've seen so far, we just have these circles, like self-standing services, very simple, very like self-deployable. But normally systems are much more complex, and some systems, especially the ones that we can implement like off the shelf, they are more they introduce their own complex architectures. They are opinionated as well, so they decide how they want to do things, both internally and communicating to the outside. So we bring in that kind of system, then we have a different problem. Right? We might have maybe a coordinator that is responsible of scaling a group of services. So we have service E, but we have several instances of that service. So then we need to load balance as well. We need to find the right instance, and yeah, we need to do several things there. So more challenges to address. And what if we have a third network with also a complex system? If we put names to this, we could say maybe the one on the left is I bring Kafka in a different network, and the network A has those original three services, and then I have network B, which also has a couple of very simple system and a fairly complex one. So then here we can see, I think, 10, 12 services. And it already looks complex. And this is just an example, because in a real organization, in a real use case, you will have not 12, but you will have hundreds, if not more, services, different nature, different networks, different systems. And you want this communication to happen securely. You don't want to leave holes in your system. You also want compatibility throughout the different layers. So with this same diagram, what are the challenges? The main ones, there are many, but the main ones that Service Mesh will attempt to resolve: service identity, as we said, compatibility in the layer 7 OSI model, right? So the network is actually our main layer of compatibility. So services, systems, whatever we have that is software, it communicates through a network. So the network is the one providing the main level of compatibility between any kind of software. So since the service mesh is something that goes at that level, at the infrastructure level, and it's mounted over the network, it also needs to provide compatibility, meaning that all of these services and systems, they shouldn't need to do anything special to be able to leverage this kind of infrastructure, as they do with TCP IP, for example. You don't need to code a system to be able to speak TCP. Systems normally do that intrinsically. So it should be the same with the service mesh. That's a concern that needs to be resolved. And decentralization, because all of these concerns we want to manage, and we want to be able to apply policies and to manage, as we said, a service identity, and to create routing rules, and to have a discovery catalog, service discovery catalog. But we don't want a man in the middle, as for example, an enterprise service bus or a piece of middleware. We don't want that man in the middle. We don't want that single point of failure in this kind of architecture. We want to push that to the edge, to the services themselves. But we still want to have something that allows us to manage this centrally. So we want to be able to go into a UI maybe and decide, okay, I want these rules to be applied. I want to allow these services to communicate to this other service. Yeah, but I don't want the services themselves to be making a call to this middleware every time they need to communicate to each other, because that's not efficient, not optimal. And as I said, it's a single point of failure, and it's actually quite insecure as well. So the service mesh should allow us to decentralize this this kind of setup, and I will explain how it's doing that. So yeah, that's exactly what we are going to do next. How does it work? How does the service mesh work? How does it address these kind of concerns? And it's actually a very simple and very beautiful pattern, if you ask me. This is basically how the service mesh works, and it has some key concepts. Let's go one by one. So first of all, the service mesh is based on a concept. This is the key part of the service mesh. It's based on a concept called zero trust networking. What does it mean? That the services do not trust the network like blindly, which is what we normally do when we don't have a service mesh. When we don't have a service mesh, the network is always trusted by default. And then that's why we need to introduce stuff like firewall rules and load balancers and IP tables and stuff like this, or rules within my application server, for example, that I'm going to only receive requests from this domain, from this IP. We use certificates as well, because we need to find mechanisms to reduce this trust and to reduce the vectors of attack, right? So what we want in the service mesh is this zero trust networking, where any service, any system that's going to live inside this mesh, it does not trust the network. The services only trust. Well, yeah, I started in wrong order, but services always trust their data plane. What's the data plane? That's basically, we call it a sidecar proxy. This is a proxy that's being run out of process, which means that it's not running in the same process as our service. It's running in parallel. It's a companion to our service. And this proxy takes responsibility for everything: network traffic, load balancing, identity, health checks, and it reports back to our control plane, which is the other main component of zero trust networking. So we have a control plane that lives elsewhere. We can decide where we put this control plane. It's normally a cluster. We can distribute it across data centers, whatever, to make it more resilient. But services are never communicating with this control plane. It's the proxies that do it. So they are like the representatives of these services, right? It resembles what happens in real life. For example, an actor, an actress, or an athlete, he doesn't deal directly with the sponsors and so on. He has a representative, an agency that's a proxy, and it's always in front, and it acts in the best interest of this person to protect the person from having to do these interactions, right? So that's what these proxies are doing. They're acting on behalf of the services, and they are subordinated to this control plane. But even if the proxies are autonomous, or even if the control plane would be out of line, out of commission, the proxies could still work and be able to do their stuff with the latest information that they have. And once the control plane is back online, then the proxies will gather the updated information. But then we don't have a single point of failure, any single point of failure. And we don't have a man in the middle, which is very important. So yeah, that's the control plane and the data plane. The most popular sidecar proxy out there, there are many implementations, but the most popular is Envoy. So most of the main service mesh providers, they leverage Envoy. Actually, it's a very good implementation. What else is part of zero trust networking? Mutual TLS certificates. That's how this works. So it's not something. It's not rocket science. It's not like reinventing the wheel. This leverages technology that has already been there for years. It just does it in a very efficient and optimal way. So mutual TLS is important in this regard. And normally, and this is not part of the service mesh tool itself, but it's critical for the service mesh to work correctly. We normally rely on a service orchestrator or scheduler. It goes hand in hand. And it can be Kubernetes, for example. It can be Nomad. It can be something else. But we normally need to have this capability of automatically orchestrating scheduling services to be able to really get the value out of the service mesh. So yeah, I will speak more about this in the next slides. Another component that has to be there, and it's normally there, is a native integration API. So not all of our services and systems will be able to participate in this kind of communication, in this kind of choreography. Right? That there may be like legacy systems or opinionated systems, as we saw, that are not suitable maybe for spinning up proxies as easily. So we don't want to work too hard on that. We don't want to fit like a triangle in a circle, so to speak. So what we can do in those fringe cases is to natively integrate with the control plane API. So the control plane has APIs. They allow us to do everything towards it. So how does that look like? On the left, we have this opinionated application with its own architecture, right? So what we can do is through our service orchestrator, we just deploy a service agent. So we don't have to be very intrusive, modifying the code of the application, just minimal modifications. And then this service agent will act as a sort of proxy, and it will have the responsibility of communicating directly through the API to the control plane, also using mutual TLS. What's the advantage of doing this? That when it comes to the mutual TLS part, we have the same certificate handling. We have the same certificate authority issuing certificates for the whole system. Otherwise, we will have to keep like separate tracks, and that's not very manageable, and that just builds up technical debt and operational overhead for us. So yes, we can bring systems that are older and that are more complicated or that are not very manageable to also participate in the service mesh, because most service mesh providers, if not all, they have their native APIs that can be also leveraged. But the vanilla way to do it, the recipe way to do it is this one. It's very simple. It works as a charm. If you have a Kubernetes cluster and you want to deploy your service mesh, that's super easy. If you have some microservices and you want to integrate them with a service mesh, it's super easy to do. So yeah, let's move along. Some examples of service mesh implementations, and this is interesting. So what are the main players in this market, in this landscape? So the most famous one, Istio. This is a tool which was developed at the company Lyft, by Google and by IBM. So it has a lot of smart people behind it, and it has a lot of work behind it. It's battle tested. So yeah, it's the most famous one. We have Consul from HashiCorp, which has become very relevant in the most recent months and years. It's also a very good tool. It also has a lot of work behind. It's simpler maybe than, it's simpler than Istio. It's maybe not as powerful yet, but it's also very well suited for working outside of Kubernetes, with Kubernetes, but also outside of Kubernetes if you have a more traditional system. So Consul, the most experience I have with Consul, and I think it's a good tool. We have Linkerd, which is also a very developed tool. So I would say, in my opinion, these are like the big three when it comes to the open source landscape. These are the most battle tested. These are the most widely spread tools. So they can be trusted. They launch Envoy. They have many use cases, good documentation. We also have some other tools, like for example, Mesh from the creators of Traffic containers. This is a nice tool. They are also very smart people, but we have, for example, Kuma from Kong. Kuma and Mesh, they announce themselves as simple alternatives, like service mesh in a very simple way. But if you look at the fact, for example, that Consul, it's a single binary, and Istio is so battle tested, and it's open source as well. So I in personal opinion, I wouldn't see the point of implementing Mesh, for example, instead of Consul, because you just have more support, more documentation, more experiences, more development on Consul, on Istio, than you had in this one. So maybe for a proof of concept, that's okay, but production, I would go with those big three at the moment, at least, because this is new technology, and you're not on the bleeding edge, but very close to it. So yeah, they say you can be on the bleeding edge as long as you're not the one bleeding. So yeah, that's why you want to go with a more robust technology. Of course, you also have the vendors, the big vendors, the big boys, right? So for example, Amazon, they have App Mesh. You have Azure, Microsoft Azure, and they have the Service Fabric Mesh. I've done a couple of POCs with these ones, and they're okay. If you are an Azure shop or a big Amazon customer and you have all your stuff there, then it might be okay for you to go with this option. Also because if you have a commercial relationship with them, then you get support. And even if something doesn't work, you will probably be able to sort it out with them, with the vendor. And the vendor has a lot of muscle and resources to be able to help you with this. But it's true also that this technology, it's being developed at a faster pace on the left side because community drives it very much, and because these companies are very specialized on this product. For example, HashiCorp or Istio, those projects, they do one thing and they do it very well, while Amazon or Azure or Oracle or any other big vendor, they focus on many things at once. So the newest features and the leading edge technologies, you will find them on the left side of this, and then they will come to the probably these vendors will imitate or will try to jump on the same train. So yeah, that's basically how it works for many technologies. Okay, so let's also dispel a couple of myths around the service mesh. This is very quite interesting. So is service mesh a service mess? This is yeah, if you look in Twitter or whatever, this is something you find very often. So people, it's the same with all new technology. There are people that are in favor, there are people that are against, and there are people that are really against and are very married to the old ways or very negative to introducing this kind of change. So many people have been labeling this as a service mess, and yeah, it might be as with any technology. If you don't implement it correctly, then you might end up in a very bad situation. But just like in nature, it's not. It's a good pattern. It's actually a very nice pattern. The technology that's being, I mean, as a pattern, as an architectural pattern, it's great because it's based actually on engineering concepts, and it resembles much more what we see in real life interactions than the previous technologies we had available for securing and integrating services. When it comes to the technology implementations, they are also really good. I think all of those technologies that I just showed, they are robust, they are really good. They have the best people developing this kind of software, and it's open source, most of them. So if you go and look into the code and look into the releases and look at the pull requests and what's going on in there, it's really exciting. So yeah, I think this is a technology a piece of technology that will really bring the software development forward. I don't know if service mesh as such as a concept is going to prevail for many years, but it will definitely help to progress, to modernize the way we develop and understand the software systems, right? So the second one, and this I really find it outrageous, like really bad. So I've seen a lot of presentations, maybe not a lot, some presentations, and they say, okay, the title of the presentation is Service Mesh, the new ESB, the new Enterprise Service Bus, and this is so far from the truth. This speaks of total misunderstanding, or if you say this, it means that you don't really understand what a service mesh is, and you just maybe downloaded and did a proof of concept and thought of something else, but it's really not the enterprise service bus, and it has to do also with the third point, the SOA, the enterprise service bus and SOA. Those are service integration tools. They have a different concern. They have some common ground, but they have a different concern. They are mostly on the platform side. like a platform as a service middleware. And the service mesh is not middleware, not at all. It's infrastructure, and it's closer to the network level, to networking. So it's not, you cannot really compare those, even if there's a little bit of common ground, but you will find common ground with most pieces of software, right? So it's service mesh is not a new service bus, and it's not so add-on, right? It's something completely different. It's a different pattern, and that was not available before. And if it was, maybe we couldn't have even had this kind of tooling. But another very big misconception is service mesh only for microservices. Not really. It works very well, microservice. And if you have a microservice architecture, you are probably good if you adopt a service mesh. It will be very helpful. But it's not only for microservices. As we saw already in the past slides, you can integrate legacy systems into your service mesh. You can bring in any kind of application, even if it has an opinionated architecture. Even if you have a monolith, you still need to secure service communication within the monolith. So that's, and service mesh can do that. Then you just need to select the right technology provider. So if you're not in a microservices world, in a Kubernetes world, for example, then you will probably not pick Istio. Then you maybe use Consul, might be. So an Envoy. So that's, but it works for everything, because again, this is not a middleware tool. This is a infrastructure thing. It's a structural concept. So it goes at your network level, and the network is there regardless of whether you're doing microservices or not. And the same goes with Kubernetes. And this misconception probably driven by Istio, which is the most famous of these tools. So Istio is tailored for Kubernetes, yes, but it's not the only tool that does service mesh. And therefore, service mesh is not only for Kubernetes. So you can work with service mesh outside of Kubernetes. You can work with service mesh outside of microservices. Even if you are in Kubernetes, then service mesh will be really good for you, because yeah, it's the right tool for the task. So those are the myths that I wanted to dispel. And finally, key takeaways. These are very important to me, at least, and they are also based on my own experience in real projects, in real life and production cases using the service mesh. So again, keep in mind, service mesh is an infrastructure pattern. This is super important. And therefore, in order to implement the service mesh successfully, the first thing you need is good infrastructure people. That's super important. And if we go back to the first misconception, the service mesh, I have seen that it's very common that since people don't understand what service mesh is, they just hear the buzzword, they just jump into the hype cycle. Then they say, okay, we want to test out service mesh. Who can do this? Yeah, let's put these integration developers to the task. These guys or girls, they used to work with Oracle Service Bus, or maybe with a TIBCO, or with something of the sort, with an application server. So they should be able to do the service mesh as well, because they believe this is a piece of middleware. And it's so far from the truth. If you want to be successful in service mesh, you need to start with your infrastructure people, the people that understand the network, the people that understand certificates, TLS, security, that kind of stuff. You also need to understand how your systems work. And that's what I think is so beautiful about this pattern, that it makes you think about this. It's a good thing. It's not a black box. It's not something that's plug and play. It forces you to understand how your systems work. And if you have that understanding, then you will probably be successful with the service mesh. And again, you shouldn't forget that the primary concern of the service mesh is security, securing service communications. So if you are looking to adopt, to test, to try out the service mesh, it should be driven by this concern, that you want to secure your services, that you're looking for improved security, not for something else. The rest will come as a consequence, and you will have more benefits, but this is a primary concern. So yeah, I think this is my last slide. I have one with some references that you can look at those afterwards. All of them are really good, really good, so interesting. So if you are interested in the topic, just go for them. And yeah, thanks a lot. And now I can answer some of the questions, I guess.
Yeah, thank you very much, Arturo, for this very interesting lecture. We got a couple of questions and we got a little bit of time left. So there was first a question by Pierre Wilken. Did you already have performance issues because of the usage of a service mesh in your project?
No, not really. And it is true that when you bring in a service mesh, it uses computing resources, of course. And but I haven't experienced any performance issues. That's also why it's very important to have the good infrastructure people in hand, because they can help with the sizing. They can help sorting out network bottlenecks to improve the way you handle the certificates, for example, certificate change. That will penalty in performance. So at least I have a couple implementations in production already, projects, and those are performing really well. And your plane, that's aside. So then you decide how big and how powerful you need your cluster to be, depending on the size of on the scale of your system.
Okay. And there were other questions here. Tim Klöckner asked an very interesting one. Is the only way to do it kind of a big bang approach, so introduce it in one piece? Or can you introduce a service mesh piece by piece into your architecture?
No, that's a great question, really great. And actually, the best way to do it, the most recommended way to do it is piece by piece. So you bring in the service mesh, you set up as a control layer, and you select the services and the systems that are more capable or that can do this in a shorter period of time with less effort, and you start bringing them in to the mesh, right? And then you can do this gradually, step by step. They call it the strangler pattern or IV pattern, because slowly you strangle out the part of your system that you want to change. But yeah, it should never be a big bang. That's part of the point, part of the pattern to do this gradually. Yeah. As with any piece of infrastructure, that is. Yeah.
Okay. If someone from the audience wants to speak up for him or herself, then just raise your hand. Meanwhile, I've got also a question. So in your experience, what is the biggest challenge that you have to tackle in the inter-service communication functions? So I think that resilience issues, transparency, logging, outcome discovery, security. So what's actually the hardest thing to do?
I think the hardest thing to do is, let's say, conceptually or architecturally speaking, is to find the right security model, because that's something we don't often do. It's normally an afterthought when we design systems, but when you go to a service mesh, it's a primary concern. So you need to speak with the security officers from the first day of the project, and you need to agree on a functioning security model that really represents the organization. And without that, the service mesh is not going to work properly. I think on the technical side, it's just a matter of understanding how this works. The concept can be sometimes hard to digest. The concept of the sidecar and the proxy, and that the services should only listen on their loopback address, so they are not exposed to the network. The zero trust networking thing, that's you need to understand that properly, and it takes time and effort to onboard developers and the rest of the people working into this mindset. That's also, then the implementation is not really challenging, because the tools are really helpful, and it's kind of simple to do it once you have the proper understanding. Yeah.
Okay. And then another question by Tim Klöckner. So he's asking about alternatives to service mesh concept in, I would say, the microservice world. What would you think?
Yeah, what we normally do, or what we've normally done so far, is that we use load balancers and firewalls. If I go back, for example, to one of my slides, let's see. This one, for example. So how do we sort out this situation without a service mesh? Well, we normally put the firewalls between the networks, and we put load balancers in front of every system, right? So that allows us to route and to load balance the traffic. And we even might be putting firewalls within systems within the same, in front of systems within the same network. The problem with this works. The problem is that it doesn't scale so easily, and it takes a lot of maintenance cost. So if you want to do dynamic scaling, which is a requirement of a contemporary requirement, then if you are so dependent on your firewall and you're so dependent on your load balancers, it's going to take time. So you have two options there. So or normally the option is that if you know that you're going to have a lot of traffic in your network, because I don't know, let's say you're a retailer and you're in a campaign, it's Christmas, for example, then you need to scale up. Then you need, if you don't have this kind of dynamic infrastructure, then you need to overcompensate for that. So you need to allocate a lot of computing resources, wishing that that you don't reach that threshold. But either you are, if you reach that threshold, then you will not be able to service your customers. If you don't, then you're wasting computing resources as well. So that's why this solution is so optimal, especially when it comes to cloud native development, where you have hybrid systems, multi-cloud, dynamic scaling, stuff like this.
Okay, thank you very much, Arturo, for this very interesting insight. And so it's time for a break. I will switch back to German now. Wir treffen uns um 11:45 wieder hier für die nächsten